Now we see that how we can combine the Turing machine. Generally, in the Turing machine, several smaller Turing machine can be combined to form one composite Turing machine. Just like in case of the modular programming, we need to write the smaller sum module, and then finally we can combine the. So here we can construct the Turing machine for the smaller job. Then finally we can combine to form one composite Turing machine. So here we can you are going to obtain the machine that has the that can be composed of many Turing machine. So just like we have the programs, and your program can be composed of many functions. The same is here. For the some task, you can, for the big problems, you can divide the big problem. You can divide into the smaller subtask, and for every subtask, you can go for the Turing machines, and then finally combine all such Turing machine to obtain the Turing machine for the original task. So here, actually, you can say like this: for obtaining the composite Turing machine, you can have, say, we are obtaining the composite Turing machine T, then T can be obtained from the T1 and T2. So here what we are going to do, Turing machine T1 and T2 are combined, and this means what? Here you can say Turing machine T1 and you have the Turing machine T2, means once Turing machine T1 halt, the T2 starts, and once T2 halts, then actually the Turing machine T halts. So for the simplicity, we can assume that T1 and T2 have disjoint sets of non-halting states. Okay, and you have transition function for the T1 and you have the transition function for the T2. So once T starts, then for this for T1, it is going to use the transition function for the T1, and using the transition functions for the T1, it is going to compute for the given input, and once T1 halt, then the execution of T2 starts. Then your Turing machine T is simulating the moves of T2, means it is executing the transition function for the T2. And once T2 halts, then T is going to halt. So when T is going to halt, T halts, T halts if T2 halts. T halts if and only if T2 halts. So you can say T halts, T halts if and only if T2 halts. Okay, so when T2 halts, then T halts. To T crashes, the Turing machine T crashes, T crashes, T crashes if T1 crashes or T2 crashes. So when when T1 is going to, when T1 executes, then if T1 is going to crash, then T is going to crash. If T1 is not going to crash, and once T1 halt, then T2 starts, and if T2 is going to crash, then T is going to crash. So T is going to halt successfully if and only if T1 halts and T2 halts. So once execution of T1 completes, T2 starts, and when T2 halts, then T is going to halt. So this is sometimes unconditional. You can combine the Turing machine just like the condition. You can give the conditions. So conditional, what you can do, you can say that this you can mention, this you can also mention like this: T1, T2. This is unconditional. So instead of writing this, you can also mention like this: once T1 is going to execute, and when T1 halts, execution of T2 starts. On conditional, So how you can put the conditions? So you can say that we have the Turing machine T composed of T1 and T2. So you can put the condition T1 executes once T1 halts, and when it is halt and your tape head is scanning the symbol A, then execution of T2 stop. So this is the conditional call of the Turing machine T2. So we have the composite Turing machine T. How T we have defined? T1 starts execution, and once T1 halts, then tape head of T1 is, is scanning the symbol A. If tape head of T1 is scanning the symbol A once T1 halt, then execution of T2 starts. This is. So this you can say that just you can say T1, T dash and T2. Where T dash is what? T dash is what? T dash can be T dash can be like this. So you are going to start from the initial state, okay, and you have the A. You are replaced with A and stationary H. So this is the T dash actually. So T dash says that A T dash. This is the T dash. What is the tape head is scanning the symbol A, and we are not going to change this tape symbol. We are replacing with the same symbol, and you are making the tape head stationary. Means tape head is scanning the symbol A once T dash halt. So T1, T dash T2. This means you are saying that T1, T dash T2 means once T1 halts, then T dash executes, and once T dash halts, then T2 starts. Why it is so? This is the same. Means once how this is possible when T1 halts, it means the T1 is scanning the symbol. Tape head is of T1 is scanning the symbol A, and when this happens, then start of T2, T2 execution of T2 starts. So T dash is like this. You can see. Okay. Sometimes you can have the situation like this. Okay. So okay, you are it's you are at the state q0. You are having the q0, and then from the q0 you can have the Turing machine T, and you are going to execute T, and you are coming back to q0, and once you are at the q0, if you have the tape is scanning the symbol B, replace with B and stationary, and you are going to the alt state. So what is this? In this Turing machine, what you are going to do? You are starting from the Q0, and when tape head is scanning the symbol A, execution of T starts, and once T halt, and tape head symbol is A, tape head is scanning the symbol A, then again you can start T. And once T halt and tape head is scanning the symbol B, then your Turing machine, composite Turing machine is going to halt. Okay. So this you can also say like this, means you are at the state q0, same you can mention q0, and when you are at the q0 you have the A. Okay, you are replacing with A, and you have the keep the tape head stationary, and you are in some state. When from this you are going to start the execution of T. Okay, and once T halts, you need to see that when T is going to halt, what are the situation. When T halts, then you can see that whether it is A or whether it is B. If it is B, then you are going to finally your composite Turing machine is going to halt. So this is the situation. So this is same, either this is same. So A means you are conditionally you are calling T, and here just like we have done T dash, this is just instead of writing this, you can also mention like this. Once you are at the Q0, if tape head is A, scanning the A, replace with A, keep the tape head stationary, and then start the execution of T. And once T hard, again you see that what is the tape head symbol. Once tape head symbol is scanning the A, then you do the same thing. Otherwise, when it is B, then you halt. Finally, your Turing machine is going to halt. Okay. So this is the composite Turing machine. So this you can do. You can have instead of Q0, you are going to you are having the T1. Okay, and once T1 halts, you see that if it is A, tape head is getting the symbol A, you are executing the T2. Okay, otherwise if tape T1 halts and when tape head is getting the symbol B, what you are going to do? You are going to halt. Means you can say like this, you can halt. So this is the Turing machine T1. When T1 halts and you see that the tape head is scanning the symbol A, it is going to execute the T2. If it is the symbol B, you are going to halt. So the same you can also mention like this. You have the T1. When T1 completes, you have the tape head is scanning the A, you start the execution of T2. When you have the T1 and you tape head is scanning the symbol B, then what you need to do? You have to do the same thing. Means you have B replaced with B, keep the tape head stationary, and finally halt. Yes. So both are same. So this is the way actually you can combine the Turing machine. So sometimes you can combine conditionally, or sometimes we don't want any condition. As soon as the execution of first machine start, the execution of next machine start. Or see some conditions, then you have to see that once Turing machine is halts, then what are the tape head positions, and according to the symbol is being scanned by the tape head, you can decide whether you have to start the execution of other Turing machine or you can do some other jobs. So this in on condition also you can call, just like on condition you can call the functions. Sometimes without conditions you can call the function, or sometimes you can give some condition, and once the condition satisfies, then you can call the function. The same thing is here. So this is the way we can say that you can combine the Turing machine, and once you combine the Turing machine, you are obtaining the composite Turing machine. So composite Turing machine. Okay. So you have obtained the composite Turing machine while combining the smaller Turing machine. Let us see one example. So we are going to construct the Turing machine for the concatenation. So what we mean by this? This means we are going to execute the functions, say cat, concatenation. Now what we are going to do? So in this case, we have the two strings taken from the sigma star. So we have the two strings, and output of this cat function is what? We have the one bigger strings. So you have the two strings, and you have just combined the two strings to form the bigger. This is the cat. This we are going to achieve. So we need to construct the Turing machine for executing the function partial function cat. So your machine, we need to construct the machine. Your machine should start from the configuration. Let the configuration of your machine we start from the state 0 q0, and we have the two strings. One is x1. So at the square 0 we have the blank space, blank symbol, sorry, blank symbol, and immediately after the blank symbol we have the input. So this is input 1, means x1 from this sigma star. Then we have the other strings x2. So x1 and x2 are separated by the blank symbol, and immediately after x2 is blank. So this is the condition at the beginning. Once your machine start, you are in the some state, say q0, you are at the state q0, and whenever you are at the state q0, this q0 is the initial state for the cat. So when you are at the q0, blank square 0 containing the blank symbol, your tape head is scanning the blank symbol. Then x1, immediately after the blank symbol we have the x1. X1 is and x2 we separate by using the blank symbol. What we need? We need to concate x2, x1 and x2. This we need. So once computation is done, then we are going to obtain the configuration, say HA, and we have the blank symbol, and you have the x1 and x2, and your tape head is carrying the symbol at the square 0. This we are going to obtain. So starting from this configuration, this is the initial configuration. This is the initial configuration. Okay. We are going to obtain this final configuration. We are interested. Final configuration. We are interested with this configuration of the machine. Okay. So here, where q0 initial state. q0 is initial state. So this is the initial state. Okay. So how we can construct? So let us construct a Turing machine for the cat. We are going to construct the Turing machine for the concatenation. So let us start with the starting from the state q0. So we are going to start from the q0. Say we are at the q0. Okay. Whenever you are at the q0, we have this kind of situation. So what you need to do? You need to scan the blank symbol, replace with blank, and go to the right. So once you are at the right, then whenever you are at the right, then you have the x1 and x2, assuming that sigma is consist of either A and B. The sigma consists of two symbols A and B. So what you need to do, you are in this state. Okay. Whenever you are at this state, you are having the first symbol of the x1. So x1 can have either A or B. So if you have the A, replace it with A and go to the right. If it is B, replace with B and go to the right. Okay. So whenever you are doing like this, you will meet some. Whenever you are doing like this, then you are scanning the x1, then you have the blank symbol. As soon as blank symbol comes, whenever you have the blank symbol, this is the blank symbol, then what you need to do? You have to call the Turing machine for deletion, because we have seen that Turing machine for the deletion we have called for the when the condition is like this. Now the tape head position, whatever symbol is here at the tape head position, we need to delete it, and we need to shift the entire Z one position left. So that's why this is the condition mean. So on condition we are calling the delete Turing machine we have constructed earlier. Okay. So this is the Turing machine for the deletion. Actually, you are devising the Turing machine that deletes the symbol, and then you shift the entire, after deletion, for filling the gap, you are shifting the entire right side string to the one position left, and your tape head is scanning the symbol, first symbol of the set. So this is the Turing machine for the deletion. So once this is done, then actually we need to call the Turing machine delete. So here, whenever the tape head is scanning the symbol blank, means now we are going to delete this and shift the entire x2 into one position left. So for doing this, actually you have to call the Turing machine delete. So when this is the conditional call, this is the Turing machine delete. So whenever you have the delete, you are going to execute like this. So see, so you don't require to construct the delete here. You have already constructed the machine for the deletion, and the conditions for executing this delete machine is met. What conditions? Your delete machine is deleting the symbol under the head position, and similarly here we are scanning the symbol A and B and going to the right, and whenever you have the blank symbol, this B we want to delete, and this we want to delete means on once you have the blank symbol, on conditional you are going to call the delete. So what you need to do, since you have executed the machine delete, so what is the condition after this machine completes? We know that once you have the deletion, okay, so whenever you have the deleted the symbol A, then what is the condition? Y, Z. So your Turing machine is scanning the first symbol of your Z. Okay, first symbol of your Z. So this can be blank, and so what you need to do, actually we need to position the tape head at the beginning first. So instead of going to the right, you have to keep the left. So this is necessary. Why it is blank? Because x2 can be null also, so this can be blank. Okay, so you can also have the transition for the B, replaced with B, come to the left, or you can have the A replaced with A and come to the left. So x2, actually you have the condition, you can become the condition x1 and x2, and your tape head is carrying the first symbol of x2, and here actually you have the blank symbol at the beginning, square 0. So this tape head is carrying the first symbol of the x2. So this can be either A or B. You are moving to the left, and if x2 is null, if x2 is equal to null, then you have the blank symbol. That's why you have to also keep the blank symbol and come to the left. What you need to do next? You are at the state, you are here, and you can have the loop where you can scan this. So you have the A replaced with A, come to the left. You have the B replaced with B and come to the left. Okay, whenever you are doing like this, you have the blank symbol. So whenever you have the blank symbol, what you need to do? Blank, replace with blank, and you are moving the tape head stationary, and this is the HA. This is the state, halt state. Okay, so anything else? That's all. So once this machine halt, when this machine halt, what is the condition? Your machine halts in the HA. When the Turing machine halts, you have x1 and x2. This is the configuration. And from here, what is the configuration? You are at the Q0. You have the blank symbol at the state at the square 0, and you have the string x1 blank x2. So this is the initial configuration, and by making the sequence of moves, your machine is able to obtain the final configuration. So from this configuration, okay, by making the sequence of moves in the Turing machine, this is the Turing machine, say for example cat, we name the Turing machine cat. So for doing the concatenation, so by making the sequence of moves in cat, you are able to obtain this final configuration starting from initial configuration. So this is the example. This is one of the example where you have called the Turing machine, just like we generally call the function in the main program. So you are calling the Turing machine. So this shows that you can for the small task you can construct the Turing machine, and for obtaining the bigger machine you just call the smaller Turing machine. And you can give, once you call the smaller Turing machines, once you call the Turing machines, then you should your tape height and your configuration of the Turing machine should be such that so that you can start the execution of the calling Turing machine. Means if your the Turing machine you are going to call which starts from the symbol, say for example A, then you have to call the Turing machine when your tape height position is scanning the symbol A. So this you need to only consider. Okay. So this is the example. You can obtain some more examples. Take some big problems, divide that big problem into the smaller problems, and for the smaller task you go for the Turing machine, and finally for obtaining the solution of your big original problems you need to combine the Turing machine, mean you need to call the Turing machines for the smaller task you have constructed to obtain the big composite Turing machines. So this is just one example. You can explore more. Okay.